It on? Ah! Hi everyone! How's the second day? Everyone is still awake and motivated and yeah. and. Hi, I'm Mario. I work for Kubermatic. I'm there for a customer delivery architect, which basically means that because titles are funny, so we put everything that I do into Gemini and ask Gemini what is my title. That came out. So I'm a customer delivery architect there, but I also work in the Kubernetes project in SIG contributor experience and in SIG infra. And you might know, you might think, what the heck is SIG contributor experience? I do this. I have stupid ideas. The stupid idea that I basically had here was, hey, let's put in the birthday of Kubernetes inside of the Twitter account. We did this, and this went well. This happened because you're not allowed to have a Twitter account when you're not yet 13 years old. So we need to wait 3 more years until we can have the correct birthday in our Kubernetes Twitter account so that we get the balloons. However, who likes Kubernetes? I also like Kubernetes. Now let's build an AI platform on Kubernetes because someone wants to have an AI platform built on Kubernetes. And we all like Kubernetes, right? And the good thing what we like about Kubernetes is like we can have those custom resources, everything can be in a, we can define everything so we can separate it in some kind of way, so we can put everything into namespaces, we can put everything into small chunks, we can we can write our own CRDs, and everything is great, right? And the tool set that we have is really, really small that we can use. It's just a couple of tools that is not overwhelming at all, and it's not like growing like every week. I think the last time I asked Jiffy, who is the product manager for all of the CNCF projects, is like, what's the current number? It's 168. And then I asked him 1 week later, what's the number? Yeah, it's 187. And it's like, you're mad, right? You add more and more projects. So, and also what we are missing there is languages, right? So we have Rust, we have Go, we have all of the other languages that also need to come into this. So we have even more problems because we also want to have multi-tenancy. We want to have it spread. It should be everywhere available because this is my single cluster that I have now. Who has more than one cluster? I think all of you, because this is not the reality anymore. This is the reality. We have a ton of clusters. They're distributed. We have them running in Europe. We have them running in the US. We have them running in China. We have them all over the world. We have everywhere we have namespaces. Everywhere we have deployments, and people are using our cluster because some department said, hey, you can use this cluster, you can deploy your stuff in there. Yeah, that's working always great, and it's not creating a mess anymore. And we need to connect all of those things because I need access to things that go in this cluster, and I need access to those things. And then we came up, let's build bridges. Let's add more and more connections into it, and we automate things. We use Argo CD to roll out stuff. We add every more layer of connectivity to it. We add a service mesh, and that makes it even more easy, right? And then we started like, hey, we need a platform to build everything on top of this. So we started like, let's build Kubernetes platforms like Kubermatic is doing, like, yeah, running multiple Kubernetes clusters, managing multiple Kubernetes clusters. So we add another layer of complexity to this. And this works really, really good. Everything is working in an amazing detail, and it's not hard to integrate. It's easy to onboard people. No, it's not. So we have the problem. We have a great technology. Everything was built that we can run our stuff in a simple and easy way. And how many people do we need to manage this? How many people do we have in our industry? Yeah, it's one person and and now my microphone is dead. And one person is basically, hey, do you even sleep? So we need to do a shift, right? So we need to, we are going back into our childhood. I could put in a Duplo. So Duplo would also be an option there. So we started with the boxes with Duplo stones. That was the Kubernetes beginning. And now we need sets, right? We need to go with sets. We can still do amazing stuff with things that we have in sets, but we need to move into a real world. So our reality check. Kubernetes was built to run containers, and it's really good in doing this. It was never meant to run platforms. So we like Kubernetes. What do we like about Kubernetes? What do you like about Kubernetes? Yeah, and basically everything can be as code, right? So you have APIs. So we need something that we have the good things of Kubernetes for platforms. And Kelsey said this when 2017. Kubernetes was never meant to build platforms. It's just one tiny part in our platform world. Because also the personas that use those stuff are changing, and it was never supposed to be the end game. And Tim Hawkins said last year at KubeCon in Chicago, Kubernetes is boring now. And it's good that we are at the state that Kubernetes is boring now, because it also means that it's stable and we can use it as another building block below everything that we have. So we need to look into who are our personas that we have now. So who is the people that are using those platforms? So we have basically 3 personas in most of the companies. So we have platform owners. They are the poor folks that need to maintain all of this stuff. Like we heard in the talk before, like you don't want to trust a dev to manage your Kubernetes clusters, because no, there are reasons for this. You have service providers, you buy services, right? So we have a lot of companies that say like, yeah, we get this service and this requires a container platform. We need, you buy software that runs in a container. You have the requirement from your business department, hey, I have like 5 million pictures taken out of our manufacturing line, and we are taking images of all of the different steps and want to analyze them. Where can we run our analyzation on top of it? So we need to build like, we have different service providers that need to interact with a platform. If every one of those needs to know how to run Kubernetes, we have a real problem, because then everyone needs to be a Kubernetes expert, and it is not working. And of course we have users, and users don't care. And there I disagree with the talk before this. Users still don't care how Kubernetes works. They just want, I want a database, I want something running somewhere, I want a certificate, I want a repository. They don't care where it is running. They don't care if it's Kubernetes, if it's a VM, or if it's a bare metal thing that is inside of my office. They just want that it runs. So let's have a look at who are our personas in detail. The poor folks, probably one of you, the platform owners. So the platform owners, you are the ones that are enabling other folks. So you're building the platform that you want. So you want to build a well-defined framework and that is easy to use. So when we saw the picture in the beginning with all of those different layers between, we want also to have it stretched. We want to have it across clouds. We want to have it across data centers. We want to abstract the complexity, because in the end, nobody cares if it is running in GCP, if it is running on Civo, if it is running in AWS. You just want to have resources where you run your parts of your platform. So it also needs to scale horizontally. So we need to add as many things as possible. And I don't want to do this every time again. So I need a template. I need a template for any location, any word that I add into this. So we need to keep it, take the complexity and make it simple. And this is always how it works, right? So we have a complex problem and you don't want a complex solution, you want an easy solution. And the problem is that Kubernetes itself is relatively homogeneous. So it's performing on the small part that it can do. It can run containers. And then we have the huge ecosystem around this. And the problem is that products are also developing into this world, and that's saying that, okay, we can run on Kubernetes, but they are also evolving, and then they have also more and more requirements. So platforms need to take care of the evolvement of Kubernetes and also of the evolvement of the different products that you want to run on this. So you don't want to build this. Your users want building the applications that are running on those things. You don't want to care what they are building, because if you would care, you would basically limit everything, and you would have to influence everything that runs on those platforms. So you shouldn't care. You're not the one that decides that if Java is a good language to run inside of a Kubernetes cluster. You're not the one that is deciding like, hey, let's use MongoDB or let's use Elastic or any other database or service. So a platform is there to bring the value that I can provide the service, the tools and services, and not care what it is. So give them services to consume. So we are not enforcing them for you, so we are building a platform that is not enforcing. Then we come to the next person. The next person is the service provider. The service provider can be external, internal. They are your database team. They want to still to exist for whatever reason. You have just different parties. You have even people that are from BI that just say like, yeah, we just need numbers, but we need to run our number calculation things. So we need services that can run on those infrastructures. The problem is that we need this in a reliant way, because just having multiple platforms is not like, hey, I have the Helm chart installed n times throughout the environment, right? That's not the correct approach, because then it's not stretch, it's just a copy. So we need to create services that run multi-layered, multi-clouded, and they have this, but still have the same level of being non-complex to the outside world. So what we do is we have a tool set that runs single region and also runs multi-region. But this is also a change in like, how do I provide those services? And this means also to stretch across clouds or worlds. So we basically need to build an environment that can support services in an easy way, also with access management, distribution, and build a platform below it that supports such different worlds. And this is not possible in Kubernetes. So we are working towards services as a product inside of our platform. And how do we do this? The problem is that if I have a CRD, who has copied a CRD into another cluster? Did it work well? This is not convincing. This is not a convincing nod. So how do you synchronize them? How do you keep updates on them? How do you keep them on the same version? Can you have canary deployments? Can you have rolling updates for users? Probably not. So Helm, does it help? Yeah, for the first installation, maybe, and then. But as we know, nobody is updating clusters and anything, so that's fine. So yeah. So basically, I want my service providers not to be the ones that are responsible for distributing this into the platform layer. So I want my service people to build a service because that's their key competence. That's what they do. That's what they have. And I also don't want them to take care of who gets access to what, because probably they don't know, because they don't care. They are a third-party company. So we need to take away this complexity. So, and the one thing that we always thought, like, okay, we have services, but what is a service? What is a service? Is CPU or compute a service? Yes, it is. Because compute is just another service. It's just the same thing like a registry. It's the same thing like a database. It's just like a resource that we consume. So compute is just another API because I deploy something that needs compute. So a Kubernetes cluster is a resource or is a service, not a platform. So compute is still there. We have still Kubernetes. So basically, a service Kubernetes gets as a service there. There, we already started this with Crossplane and Argo CD or Flux for automated rollouts and stuff like this. But we still want to add this to all of the other services. So we come to the last person that we need, which is the user. They see this, right? So we have they see all of the things that we had before, and now we want them basically to have their stuff running on there. So they want to have like workspaces, and I say workspaces because when I come to the project that was basically solving this whole platform issue, there's a name correlation there. So we basically need workspaces that are connected to each other, that can talk to each other, but are also separated, and they basically have a multi-tenancy. So basically, what the user wants is this. They only want to see this. They only want to see their services that are available to them because they don't care about the underlying structure. So they don't care about the application. The application they care about, but they don't care where it's running, if it's in the cloud, if it's not in the cloud, if it's in a data center, if it's anywhere else. So what we want to have to solve this is a unified API. And we already said Kubernetes APIs are great. So KCP. KCP is basically Kubernetes-like control planes. So it's control planes without compute. You can run them anywhere. They work the same way as Kubernetes APIs. They are in a declarative style. And they have this workspace approach. So you have, in Kubernetes, you have namespaces. There you have workspaces. And the cool thing with workspaces is you can basically make a tree of workspaces. So you can move stuff in workspaces, in workspaces, in workspaces, and there you also have your access management, which means that you have access to, if I'm the admin, so I'm root, I don't see what's there because I don't care. They basically, the idea to have this is that you have, that you can create basically a tree with multi-tenancy, with access management, and people only get access to specific parts of your application. And you also have the separation. Usually in the CRD you have like, what is it doing? What are the rights for it? Who can access it? And in KCP you have a differentiation between this. So you can basically have the service provider API that provides the services. So this is where your service providers create their application, which can be like a certificate service, which can be a database service. And on the other side, you have multiple API consumers that are just consuming the service. They will never, ever change the service. And it's basically, it's a building block for creating APIs. And with this, you can basically automate also, like, I want to have a cluster as a resource. So I can basically merge everything into this and say, I have a cluster as a resource, I have a repository as a resource, and I want to have the different parts as a resource. And with this is KCP. It's an open source project. It's in sandbox status in the CNCF. You can check it out on kcp.io. It's in active development, and the sponsoring companies are Upbound and Kubermatic. So it's there. You also have support if you need something, and you're very happy to test it out and look into this. And with this, I managed to get back 2 minutes, and I have 5 minutes for questions and 3 before the next speaker joins. Thank you very much. Have a nice conference, and see you at KubeCon. Any questions?
Are you using it?
Yes. We are building a development platform based on top of it. Obviously. Yeah, so we use it we started developing it, and then we integrated as a core functionality into our platform. Yeah. It's great.
How are you using it?
As the baseline for defining services. So basically, you can imagine it as the API builder. So you can basically use KCP to build APIs, and we also do the rights management. So for example, you have a service catalog, and the service catalog is created. There's a service created for repositories, and this service basically says, okay, I have the rights to create repositories, and then I can add users to the service, and they can consume the service, but the service is decoupled from rights. So you can say, this is my access key, and just create repositories out of this, or create certificates out of this, or create Kubernetes clusters out of this. So you can automate not only your infrastructure, but your whole cycle, because everything is more or less YAML file. Everything is code. All right, then enjoy the rest of the conference, and thank you very much.